Good morning, and welcome to the second part of our lesson on the slope-intercept equation. So you'll recall that yesterday, or last class, we took a look at the slope-intercept form, and remember that takes the general form y equals mx plus b. And remember, each of these variables has an important function. B is the y-intercept. And remember, that's the point where the line crosses the y-axis. M is the slope, which, remember, tells you a lot about the line. It tells you whether the line is going up as you go from left to right or down as you go from left to right. It tells you how steep the line is, and it also can give you directions. If you only know one point on the line, it can also give you directions to get to a second point. Okay, so it gives you a lot of information. Y and x can simply be any y coordinate or x coordinate of any point on the line. Okay, so there are times, and we'll do this in today's lesson, there are times when you may not know what the slope is, but if you know a y and an x coordinate, if you know one point on the line, and if you know the y-intercept, you can plug all that information in and you can solve for your unknown value. Okay, so we'll be doing some of that today. The last thing we did in the last lesson was, given an equation, we found out how we can take that equation and graph a line by rearranging the equation into y equals mx plus b, into the slope-intercept form, and then plotting the y-intercept and using the slope to find another point. Once we have 2 points, we can just join them up and there's our line. And more generally, for any line, if you have the equation, all you need are 2 points or the slope and 1 point. So all you need are 2 bits of information about the line, either 2 points or the slope and 1 point, and you can use that to graph your line. Now, an easy way to graph a line, other than putting it into y equals mx plus b, is to use the equation of the line to find the y-intercept and the x-intercept. And for people who don't like rearranging equations all that much, this might be preferable. Okay? So we're going to do one example of that, and then we're going to move on and we're going to look at some word problems that take linear equations into account. So if we wanted to graph this line, we could rearrange it to y equals mx plus b. That would be one way we could do it. However, sometimes it's important to figure out what the intercepts are of that particular line. So where does it cross the x-axis and where does it cross the y-axis? Now remember, for your x-intercept, we already know that since it crosses the x-axis, it's going to have a y-coordinate of 0. For the y-intercept, since it crosses the y-axis, we know that wherever it crosses the y-axis, it's going to have an x-coordinate of 0, because all points on the y-axis have an x-coordinate of 0. All points on the x-axis have a y-coordinate of 0. Okay? So, knowing that, it makes it a little easier to graph. Okay? So, if we want to find the x-intercept, we can take our equation, and knowing that the y-coordinate will be 0, we can substitute we can substitute 0 wherever we see y in our equation. And what that does is that gives us an equation with only one variable. And with only one variable, it's easy to isolate it. Okay? So let's simplify the left side. 3 times 0 is just 0. This entire term will disappear, giving you 2x equals 6. And then dividing through by 2 gives us a value of x equals 3. Well, what have we just discovered? We've just discovered one point. Okay? X equals 3. So we know that our x-intercept point is at 3 and 0, and we can plot that. Okay? So our x-intercept is going to be right here at 3 and 0. We can do a similar thing to find the y-intercept. This time we know the value of x, so we take our original equation, 2x minus 3y equals 6, and it becomes 2 times 0, right, value of x, minus 3y equals 6. And again, just as we found in the first case, this term will disappear because 2 times 0 is 0. That will leave us with minus 3y equals 6. And then if we divide both sides by the thing we're trying to get rid of, the negative 3, we end up with y equals negative 2. And that's our y coordinate at the y-intercept, so negative 2. And we can plot this point. So 0 and negative 2 is right here. Look at that. Just let me write the coordinates. 0, negative 2. As soon as we have 2 points plotted, if it's a linear equation, we can join them up. We're done. So, just another way to graph a line by finding the two intercepts, the x-intercept and the y-intercept. Okay? Okay, let's move on and we'll do a couple of examples that are word problems. So, it says the graph represents the height of a float plane above a lake as the plane descends to land. Determine the slope and state the h-intercept. Now they're calling it the h-intercept because your y-axis is height, but what they really mean is the y-intercept. Okay? Now, if you have a graphed line, the y-intercept is pretty easy. It's simply the point where the line crosses the y-axis. Okay? So our y-intercept, in this particular case, it's between 800 and 1,000. So the y-intercept equals 900 meters. Okay? The coordinates for the y-intercept then would be at 0, 0 time, and 900. Okay? So the y-intercept is 900. What's the slope? Well, remember, in order to find the slope, we have to use the slope formula. Okay? So we have one point here. We may as well use it. Here's another point that they've given us, and the coordinates for that point are the value of x is 5, and the value for y is 500. Again, don't make the mistake of just counting squares, okay? Because this is 1, 2, 3, 4, 5 squares up, but it actually is 500 as a value, okay? So, we've got our 2 points, 0, 900, and 5, 500. We can use those in the slope formula, m equals y2 minus y1, x2 minus x1. Plug in the values. y2 minus y1 becomes 900 minus 500. x2 minus x1 becomes 0. Remember, if we put the 900 first, we have to put the x coordinate that goes with it first. So 0 minus 5. and that gives us a slope. 900 minus 500 is 400. 0 minus 5 is negative 5. And that will simplify to negative 80. And remember, slope is a rate of change, so we have to include the units. In this case, our y units are meters, and our x units are minutes. So, negative 80 meters per minute would be our slope. Now, we have the slope, we have the y-intercept, so part B asks us to write an equation to describe the graph. Well, remember, if we have the y-intercept and we have the slope, the easiest way to do that is with our slope-intercept form, y equals mx plus b, where m is our slope, so y equals negative 80x, and b is our y-intercept, 900. So there's your equation. Y equals negative 80x plus 900. Now, this is perfectly correct. You could also use the variables that they've given you. So you could also write this as, instead of y, we can say h for height equals negative 80, and instead of x, we're going to use t for time plus 900. So h equals negative 80t plus 900. Either one is perfectly correct. Okay? Let's get, we got some space. Use the equation to calculate the value of h, so there we go, there's h, when t, there's t, is 5.5 minutes. So what they're saying is, how high are we at 5.5 minutes? Well, you can interpolate and get an idea. There's 5.5 minutes. If you go up to the line and then across, it's probably going to end up being around 450, okay? But they've asked us to use the equation, so we got to do it. So, what we'll do is we will take our equation, h equals negative 80t plus 900. We will substitute our value for t, so it becomes h equals negative 80 times 5.5 plus 900, okay? 80 times 5.5 would be h equals negative 440 plus 900. H equals negative 440 plus 900 is 460. So you can see that by interpolating we got pretty close. We said it was about 450. 460, and since it's a height, we include the units. 460 meters, okay? So that's how high this thing is after 5.5 minutes. It's important that you be able to extract information from a graph, as we did in the last example. And here are just some examples. Okay, it says match each graph to its slope and vertical intercept. So the first thing you should do, probably because it's the easiest thing to do, is just very quickly take a look at each of these, figure out the y-intercept, and at least whether the slope is positive or negative. Those are really easy things, okay? So this one crosses the y-axis. It has a y-intercept at negative 8. So b equals negative 8. And we know that since the line is going up to the right, we know that slope is positive. How about this one? Well, this one crosses the y-axis at 10, and since it's sloping down to the right, the slope is negative. This one crosses the y-axis at -8, and since it slopes up, it has a slope that's positive. Okay? So, with that information, we don't really even have to figure out what the exact numerical value is for the slope, because if we look at this, we can see vertical intercept of -8 and a positive slope. Well, that must be this one, graph A. This one, also a positive slope, vertical intercept of -8. Now, all of a sudden you say to yourself, hey, wait a minute, how am I going to tell? Oh, take a look. This slope is twice as big as that slope. That means this slope will be twice as steep, okay? This slope is going to be much steeper than this slope, and if we compare the two that have a y-intercept of -8 and a positive slope, this line is much steeper than this one, therefore this is graph C. Okay? Steeper slope, bigger number. Finally, this one's pretty easy. It's the last one, so we can just process of elimination it. But this one has a negative slope. There we go, we're going downhill. Has a vertical intercept of 10. We figured that out. We're so smart. There you go. Okay? So you need to be able to, by looking at a line, say something about the slope and the intercept. Moving right along. What does the vertical intercept indicate for each graph? This one indicates the temperature at the start, the temperature at the start, the temperature at the start. What does the slope represent for each of them? It represents temperature change, right? Delta Y over time change. So, delta Y over delta X, okay? In this particular case, degrees Celsius per hour, okay? Sometimes they're not so nice. They don't give you a graph, so it's not quite as visual. It's a little harder to work with, but you're smart and you can do it, okay? So it says an online music site charges a one-time membership fee of $20 plus 80 cents for every song that's downloaded, okay? Write an equation for the total cost of downloading N songs. So you know that the way you're going to pay, in other words, your cost, is based on your one-time fee of $20 plus a charge of 80 cents for every song you download. Okay? So, total cost equals your membership fee plus 80 cents for every song you download. Identify the slope in your equation. Now remember, I'll just write our y equals mx plus b. Burn that into your brain, guys. You're going to use it all the time. Okay? Remember, the slope is simply the value attached to your independent variable, your x variable, which in this case is right there. Okay? So identify the slope. Slope equals 0.80. What does it represent? Cost per song. And that should make sense, because remember, slope is y over x. Change in y over change in x. What is y? Y is the cost. What is x? X is the number of songs, so our slope is, in this case, cost per song. Identify the vertical intercept in your equation. What does it represent? Remember, the vertical or y-intercept is the constant term. Okay? That's the one that's just a number, no variable attached, which in this case would be 20. What does it represent? In this particular case, it represents your membership fee. Okay? So our pal Jacques, he downloaded 109 songs. What is the total cost? So what are they saying to you? What they're basically saying is n equals 109, right? 109 songs. What is the value of C? What is the cost? Well, we have an equation, so it's easy, okay? So 109 songs, so our equation becomes cost equals 0.80 times 109, right? Our value for n, in this case, is 109 plus 20. I have to get Mr. Calculator. So 20 times 109 equals, oh, sorry, 0.8 times 109. We all make mistakes. 87.2 plus 20. So if he wanted to download 109 songs, he would have to pay 87.2 plus 20, $107.20. Okay, so that would be the cost if you wanted to get 109 songs. E is just giving us the other variable. Okay, so for E, it says Michelle paid a total cost of 120. So her total cost is 120. This time, they want to know the value of n. How many songs did she download? Okay, we'll do this up here because there's more room. Okay, so C is our cost equals 0.80 n plus 20. So this time we're going to substitute our total cost, 120 equals 0.80 n plus 20. And this time it's a little trickier simply because we're going to have to rearrange our equation to isolate the variable. Okay? So, we want to get n all alone. We want to get rid of the stuff that's added or subtracted first and the stuff that involves dividing and multiplying next. So, let's get rid of this 20. We're going to subtract 20 from both sides. That will give us 100 on the left side and 0.80 n on the right side. Lastly, we want to get rid of this 0.8 because it's multiplied. We're going to do the opposite operation. We're going to divide by 0.8, again with Mr. Calculator. That gives us 150 equals n, right? This will cancel, 0.8 divided by 0.8, and that gives us 150. So, Michelle paid a total cost of $120 for 150 songs. Okay? Let's do one more, and then since it's Friday, we're gonna call it a day. Let's see. Oh, sorry. We're gonna have to do a little bit more than I thought. So let's do one more word problem. We'll do this one. So, submarines must withstand tremendous pressure exerted on all sides by the water. The table shows the linear relationship Why is that important? It tells you that you're going to get a straight line, right? Because any linear relation will form a straight line between pressure and water depth. Sketch a graph of the data. So let's do that. Remember, generally, if we're given a table of values, the left is the independent, or x, the right is the dependent, or y. Okay? So depth will go across the bottom. Always include the units. Pressure will go as your y along the side. Units for pressure are kilopascals. Okay? This goes from 100 to 850, so I'm just going to go up by hundreds. So 100, 300, 500, 700, 900. Okay? That's above our highest y value, so that's where I'm going to stop. Depth in meters goes from roughly 0 to 100. So let's see. Yeah, so I'm going to take 2 squares to be 10 meters. Okay, so 10, 20, 30, 40, 50, 60, 70, 80. And I'll stop there because 75 is my highest value. Okay? Plot the points. Now, this is where, if you realize it's a linear relation, how many points do you need to graph it? 2. Count them. 2. So, do we have to plot all these points? No. Okay? As long as we plot 2 of them, we can join them up. So, let's be lazy. Let's go easy on ourselves. The pressure at a depth of 0 is 100. So there we go. There's our first ordered pair at 0 and 100. And then let's put this one in. Doesn't matter which other one we put in. We know they're all on the line. We know it's a straight line. So let's do this one, 50 and 600. So there's 50 across, 600 up. There's our second point. Since it's a linear relation, we know that we can just join the points and we get a beautiful linear relation. Okay? Is the data discrete or continuous? Well, if you look at this, you see that they're both measurements. Partial values make sense, right? So in other words, at a depth of 5 meters, it makes sense that it would be about 150 kilopascals of pressure. You can have, those partial values. So it's continuous. And so we can join the points. Okay, if it was discrete, we wouldn't join the points. What is the slope of the line? Again, anytime they ask for the slope of the line, you're going to have to use the slope formula. So let's use the 2 points we didn't use the first time. You can use any 2 points to find the slope, but we don't want them to feel left out. So these are our 2 points, 25 and 350, 75 and 850. We'll use those to find our slope. Okay? And so slope equals y2 minus y1 over x2 minus x1. Slope equals y2 minus y1 becomes 850 minus 350. x2 minus x1 becomes 75 minus 25. That gives us a slope of 850 minus 350 is 500. 75 minus 25 is 50 for a slope of 10. And make sure you include the units. Units for y are kilopascals, units for x are meters, so it would be kilopascals per meter. So, what is the slope of the line? Right there, 10 kilopascals per meter. What does it represent? Increase in pressure per meter. What is the value of the parameter B? Remember, they're just using rather odd language to describe something that's pretty straightforward, hopefully, by now to you. Remember, B is the y-intercept. Well, what is the y-intercept? It's the place where the line crosses the y-axis, which in this case is 100 kilopascals. What does this value represent? Air pressure at the surface, right? So at a depth of 0, so at the surface of the water, your air pressure is 100 kilopascals. Okay? Finally, write an equation that models the relationship between pressure in kilopascals and water depth in meters. So let's just get rid of this. And we'll get rid of that too. So we know that the slope is 10 kilopascals. Oh no, it was 50. No, it was 10. 10 kilopascals per meter. So our equation in the form y equals mx plus b becomes, remember our y value is pressure, so pressure equals our slope, excuse me, our slope or m is 10, our x value is depth in meters, so 10 d, and our value for b, our y-intercept, is 100. So, an equation that models the relationship between pressure and depth is P equals 10d, 10 times the depth in meters, plus 100. We'll skip E, and we're just going to do a couple of examples. Now, I mentioned this to you at the very beginning of the lesson, that y equals mx plus b is really an equation. And as with any equation, if you can plug in values, leaving you with just one variable, then you can solve for that variable by rearranging. Okay, so it says, consider the equation y equals mx plus 3. What is the value of m if the line passes through each point? So, in our equation, y equals mx plus b, our general form for a linear equation, what do we know? Well, we know the value of b, right? We know that b equals 3. They've given us a point, and remember, our y-coordinate subs in here. Remember, y is just any y value of a point on the line. Our x value can also be subbed in as the corresponding x value of that point on the line. And so, by substituting in everything we know, we have a value for y, it's negative 7. We don't know what m is, but we do have a value for x, it's 5. Now I'm just going to write this as 5m because we usually write the number first and the variable second when we have a term. And then our value for b is 3. And look, we have an equation where we've plugged in all of the variables except one. So now, super easy, isolate your variable. So we got to get rid of the 3 and we got to get rid of the 5. Get rid of the stuff involving adding and subtracting. If we take away 3 from both sides, this becomes 0. This becomes negative 10 equals, 5m. And then to get rid of the 5, because it's multiplied, we're going to do the opposite. We're going to divide. 5 divided by 5 is 1, leaving us with m. Negative 10 divided by 5 is negative 2. Okay? So this particular line would have a slope of negative 2. That means it would be fairly steep, and it would go down to the right. Now, we can do exactly the same thing with an equation like this. In the first example, we were given the y-intercept and asked to find a value for the slope. Here, it's the opposite. We're given a value for the slope and asked to find the y-intercept. So again, no big deal. Take your y value, sub it in where you see y. Take your x value, sub it in where you see x. That will give us negative 5, our y value, equals 2 times negative 6, our x value, plus b. Simplify your equation. Negative 5 equals negative 12, right? 2 times negative 6, plus b. And finally, isolate your variable. This one's easier. We just add 12 to both sides. This gives us 0. This gives us 7 equals b. Okay? So the value of b in a line that goes through this point would be 7. It would cross the y-axis at 7. Okay? We'll do this one. It'll take us 2 seconds. So this one is very similar to what we just did. It's just that it's a word problem, and word problems sometimes give people grief. A decorator's fee can be modeled by the equation f equals 75t plus b. Remember, that's like saying y equals 75x plus b. There's your slope-intercept equation again. In the equation, f is the fee in dollars, t is the time in hours, b represents the initial consultation, right? Where they come to your house, they tell you how much money you're going to have to spend, but even if you don't spend any money, they still charge you for the consultation. Suppose the decorator spends 4 hours working for a client. Remember, that's this value right here. And charges the client $450. That's this value, the total cost. Determine the value of b. Okay, so we have our y value, our total cost. We have our x value, our number of hours. Plug it in. So this becomes 450 instead of y. 75 times 4, because it's 4 hours, plus b. Simplify the right side of the equation. 450 equals 300 plus b, and isolate the variable. Subtract 300 from both sides. That gives you 150 equals b. What does that mean? It means your consultation fee is $150, right? So as soon as they sit down in your house, you've been charged $150. I hope that helps to clear things up. Next lesson, we will start talking about, as you can see, the general form. So another way to write an equation. It's Friday for me, so I'm looking forward to the weekend. You have a great weekend, even if it's not Friday when you're looking at this.